Data loading is the first practical thing you do in Snowflake after setting up your environment. It's how data gets from the outside world, files sitting in S3, Azure Blob, Google Cloud Storage, or on your local machine, into Snowflake tables where you can actually query it. It sounds simple, but there's real depth here that determines whether your loading is fast, reliable, and cost-efficient, or slow, error-prone, and expensive. Three concepts to understand. Stages, where files sit before loading. Copy into, the command that does the actual loading. And Snowpipe, the service that automates it continuously. Let's break down each one. A stage is simply where your data files live before they are loaded into a table. Think of it as the loading dock. Data arrives here, gets inspected, and then moves to its final destination inside Snowflake. You cannot load data without one. There are two main types: internal stages, which are storage managed by Snowflake inside your account, and external stages, which point to cloud storage you already manage, an S3 bucket, an Azure container, or a GCS bucket. Internal stages come in three subtypes. A user stage is automatically available to every user, like a personal folder. A table stage is automatically associated with each table, and a named stage is one you explicitly create. This is the most common because you control the name, permissions, and configuration. You upload files to internal stages using the put command. The trade-off: once files are in an internal stage, only Snowflake can access them. Other tools in your ecosystem can't reach them. External stages are the most common choice in production. They point to storage you already manage, your data lake, your export buckets, wherever your source systems write files. You create the stage in Snowflake with a URL and credentials, and Snowflake reads files directly from your cloud storage. The data doesn't move until copy into actually loads it. Best practice: create separate named stages for each source or data feed. One stage for Salesforce exports, another for Stripe, another for your ERP. Don't point one catch-all stage at a root bucket containing everything. Before Snowflake can load a file, it needs to know how to interpret it. That's what file formats define. Snowflake supports CSV, JSON, Parquet, Avro, ORC, and XML. A practical recommendation: if you have a choice, use Parquet or ORC over CSV for structured data. They compress better, preserve data types natively, and load faster. The best practice is to create named file format objects rather than defining options inline. You define the parsing rules once: delimiter, header handling, null representation, date formats, and reference that format everywhere. This ensures consistency across all your loading operations. Copy into is Snowflake's primary command for loading data from a stage into a table. The syntax is straightforward. You specify the target table, the source stage, and the file format. Snowflake reads the files, parses them, and inserts the data. An important detail: copy into runs on your virtual warehouse. You're in control of how much compute is dedicated to the load. This matters when we talk about performance. Snowflake parallelizes copy into across files. Each file gets its own thread. This is why file sizing is critical. If you give it one giant 100 GB file, only one thread works while the rest of your warehouse sits idle. Split that into 400 files of 250 megabytes each, and Snowflake can use every available thread. On a large warehouse with 64 threads, you want at least 64 files for full saturation. But don't go too small. Millions of tiny files create metadata overhead that slows everything down. The sweet spot is 100 to 250 megabytes compressed per file. Snowflake tracks metadata on every file loaded through copy into for 64 days. If you run the same command again, it automatically skips files that were already loaded, preventing duplicates. This is a powerful safety mechanism, but if you need to reload a corrected file, you'll need to either use the force option to override the check or upload the file with a new name. By default, copy into stops the entire load if it hits a single bad row. That's abort statement, but you have options. Continue skips bad rows and keeps loading. Useful when you expect occasional garbage from sources you don't control. Skip file skips the entire file if any error is found. Either the whole file loads cleanly or none of it does, and skip file with a threshold lets you set tolerance. Skip only if errors exceed a count or percentage. A powerful tool most teams don't know about, validation mode. It parses the files and returns all errors without loading anything, like a dry run. Use it on new data sources to preview problems before committing. Then switch to copy into with your chosen on-error behavior. Copy into also works in reverse. You can unload data from a table back into files in a stage. Same syntax, opposite direction. Same file format options apply. This is how you export data from Snowflake to your data lake, to another system, or to a partner. Copy into is a manual command. Someone or some scheduler has to run it. For scheduled batch loads, that's fine. But when data arrives continuously, event streams, log files, IoT data, transactional feeds landing throughout the day, you need something that watches for new files and loads them automatically. That's Snowpipe. It's a serverless, always-on service. Files land in your cloud storage, Snowpipe detects them and loads them into Snowflake automatically, typically within seconds to a minute. And it does this without using your virtual warehouses. It runs on separate Snowflake-managed compute. Here's how it works under the hood. You define a pipe object, essentially a persistent copy into definition with a stage, table, and file format. Set auto ingest to true. Then configure your cloud storage to send event notifications when new files arrive. S3 uses SQS, Azure uses Event Grid, GCP uses pub sub. When a file lands, the notification reaches Snowpipe, the file joins an internal queue, and it's loaded automatically. Snowpipe also tracks what it's loaded, just like copy into, no duplicate loads. If a file fails, it goes to an error queue and processing continues with the next file. When to use which? Copy into for batch loading, nightly imports, hourly exports, one-time historical loads. You control the warehouse, the timing, and the error handling. You pay for warehouse runtime. Snowpipe for continuous loading, data that arrives throughout the day, many small files, near real-time requirements. It's serverless, automatic, and you pay per file. For large historical backfills, always use copy into with a properly sized warehouse. Snowpipe is designed for continuous trickle loading, not bulk. Many production environments use both. Copy into for scheduled batches and Snowpipe for real-time streams. Putting it together, files arrive in your cloud storage from source systems. External stages in Snowflake point to that storage. Named file formats define how to pass. For batch loading, copy into runs on a dedicated warehouse. For continuous loading, Snowpipe watches and loads automatically. In both cases, data lands in the raw database, the first layer from our schema design video, untransformed exactly as it arrived. From there, the transformation pipeline takes over. The common mistakes we see: files that are too large for parallelism, files that are too small, creating overhead, no named file formats, no error handling strategy, and using Snowpipe for massive backfills where copy into would be faster. Stages: copy into and Snowpipe. The loading dock, the workhorse, and the automation layer. Master these three concepts and you have a reliable, scalable data loading pipeline. Get this right and everything downstream, transformations, analytics, AI, starts from a foundation you can trust. This is part of our Snowflake Fundamentals series. Next up, SQL in Snowflake. What's different from other databases? Follow along to catch it.